Okay, so let's get started. We're going to be taking a look at working with our G5 specific nitrous control programming feature found in our Link G5 software. Now, this feature is specific for the G5. At this point in time, G4X does not have the natively built-in nitrous control feature, allowing you to have multiple stages of nitrous control and all the programming that goes along with it. Our last tutorial, I did a specific tutorial doing advanced nitrous control programming. We talked through how to set all that up. There was a lot of setup and configuration. What we accomplished in the last tutorial is exactly what we're going to accomplish here in this tutorial. So we're going to be looking at the same schematic and looking how we can integrate the nitrous control being a direct plug and play here for our G5s, where we had to get creative with the software and do a lot of virtual auxes and going through setting up general purpose outputs for specific control routines to make that system work. Now we have it really just built into the software. We don't have to go through all of that. So G5 at this point in time of filming has this nitrous control built into the software. G4X does not. So just wanted to be very clear as to what to expect in this tutorial. So if you have a G4X, refer back to the basic or advanced nitrous control tutorial. If you're a G5, then definitely pay attention to what we go over here in this tutorial because it's going to be more applicable. You don't have to get creative with the software and use other auxiliary tables and general outputs and virtual auxes to make things work. Okay, so what we're going to do right now is jump from our fuel page and go over to our nitrous specific page that I've built that's for the G5 software. So we're going to go over here from layout, go all the way down here to nitrous, and we can find we're in our nitrous page. Now this page is set up assuming we want to run a single stage of nitrous. So this gives us access to all the programming tables for our stage 0 spool nitrous fuel, spark, and potentially duty cycle control output if we're running pulse width modulated progressive style control. So let's turn on some things here and talk about what we have to work with, and we'll talk about our control strategy, what we're actually trying to do here. I'm going to give you kind of the most complex example, taking advantage of all the software has to offer in order to make the nitrous work properly. So we're going to go over a schematic, talking about the components and some of the wiring details so we can configure everything, and then talk about how to go through setting up your fuel, spark, and we're going to be dealing with, in my case, a dry progressive kit or dry progressive type of control for the nitrous, which requires us to program a duty cycle control. It gets a little bit complicated, but this will be the worst case scenario for programming and working with the link. Let's jump in and take a look at this. We're going to go to our nitrous control, and let's go from off and let's go to on. Now in here, we have our options to turn on our nitrous bottle pressure control, which we absolutely are going to do. Again, we'll make a little bit more sense as to why we have a bottle pressure and how that's going to all work in a second here. We look at our schematic. We have our stage 0 spool, and right now the mode is set to off. Now, technically speaking, we can go here and work with stage 0, 1, 2, or 3 right off the bat and use that for the first stage of control. But what I like to do, just to make things simple, if I'm having a single stage of nitrous, I always start off with stage 0 spool. So stage 0 is where it begins at. If you're going to be doing multiple stages of nitrous, you then have another 3 stages you can enable, calling out our enabling conditions right here, which we'll talk about. But let's assume we're having 1 stage of nitrous control. That's going to require us to go here to stage 0 spool mode, and we're going to turn this from off and then go select what we're going to be working with here. So we have a wet, a dry, wet progressive, dry progressive. What does this mean? When we're talking about a wet shot, that's where we're spraying fuel. There's a fuel jet, and we have a nitrous jet spraying the nitrous into the engine. A dry shot is where we're only spraying nitrous. So we're looking at the difference here between wet and dry. This is an on or off control. So meaning we turn it on, it's going to spray full nitrous flow, full fuel flow if it's a wet, or it's dry, full nitrous flow into the engine at whatever the jet size we're setting our nitrous nozzle to. So that could be a 100 shot. That's what we're spraying into the engine. We then have a progressive option. The progressive option allows us to use a solid state relay and pulse width modulate our nitrous solenoid to give us a lot greater flexibility and control. We can ramp in the nitrous how we want. We can do it based on a race timer. We can do it based on gear and RPM, similar to the idea of boost by gear and RPM. So we're ramping our power in based on higher gears and bringing the power exactly how we'd like. We have a lot of options with progressive control. but it does require a solid state relay where the on-off control here, so the wet or dry option, is going to be just a basic 30-40 amp relay that we're going to be turning on or off to start or stop our nitrous control. So looking here, we have progressive options, dry progressive or wet progressive. So again, wet is where we have fuel and nitrous being controlled in a progressive manner and bringing that into the engine. So there's a nitrous jet and a fuel jet. A dry progressive is where we just have nitrous spraying into the engine, and then we're going to be supplying additional fuel flow through our port fuel injectors. That's the same thing here with a dry option. So we always have to have additional fuel if we're spraying nitrous, and dry options mean that we're supplying it through the port injectors. The wet options means we have a fueled jet, and that jet is going to be jetted proportional to the nitrous jet so that we take care of our nitrous fuel ratio through the jetting and not through the port injection here, so the progressive. So what I'm going to do here is go through setting up everything for a dry progressive. This is kind of the worst case, most complicated scenario for working in the nitrous control. We can really see what the software is capable of using our dry progressive. Again, wet progressive would be fine, but I typically like to, if I'm doing progressive control, I typically like to work with just dry. All right, let's click OK. And it's going to ask me, do you want to clear some of these tables out, use default values? We'll just say yes, let those tables populate. So what we see comes active right now is a fuel compensation table, an ignition compensation table, and a duty cycle compensation table for working in our stage 0 control. Okay, so at this point, let's talk about bringing our schematic up on screen so we can talk about the individual components and some of the wiring details. Then we can configure what we have over here on the side so that it's going to work for our particular nitrous system that we're trying to program here. Again, this is going to be the worst case scenario, taking care of all of the different variables and different options we have for programming in the software. So first thing we're going to take a look at here in our picture, we're going to see that our link G5 is controlling all of the relays and the inputs and outputs, so everything is going to be functional here. We're going to notice that we have first an arming switch. The arming switch is an on-off toggle switch. It's going to be wired to a chassis ground, and then the other leg of the switch is going to go into a digital input, typically with our link. We're going to be grounding that digital input when we want the nitrous to spray. So that's the arming switch. Arming switch tells the link we're ready to spray, we have to meet the conditions, and then start to spray. Then we also have here two relays. There's going to be a solid state relay. That's the relay that has the 3 wires going into it. That's going to be a Holley part number 15620NOS. So that's actually a nitrous specific solid state relay, although it works for a lot of different applications, but it's designed for working with nitrous solenoids. So we're controlling that solid state relay, which allows us to pulse width modulate the relay, and that handles the switching load to pulse width modulate our nitrous solenoid. So we're going to see here, looking at our solid state relay, pin 3 going into that relay is going to be our 12 volt in. Pin 2 is what we pulse width modulate in a low side fashion to the solid state relay. Then pin 1 is what sends a 12 volt pulse to the nitrous solenoid. The other leg of the nitrous solenoid goes to some type of a ground. It could be chassis, it could be battery, doesn't matter. So that completes that nitrous solenoid circuit. Then we have, taking a look all the way to the left, our nitrous bottle. The nitrous bottle has a heater blanket on it. We want to control the heater blanket so that we're building a certain range of pressure, bottle pressure, so we have consistent nitrous flow coming into the engine when we want it to spray. So you'll notice here, there's the heater, there's a relay. That relay is controlling when the heater turns on or off, and that's based on our nitrous bottle pressure. So we can take a look, the nitrous line, so we have our bottle, we have the line going into the nitrous solenoid, then we have our nitrous pressure sensor. That's a 0 to 2000 PSI Calvico sensor. We're going to talk about how to set that up here. And then the actual blanket heater controls done through the relay. So this is pretty simple. We have standard 30 amp relay. Looking at the pins, pin 86 is going to a 12 volt power source. Pin 30 is going to a battery power source. Pin 85 is what we low side ground from the link to turn on the relay. And then pin 87 is going to the nitrous bottle heater. The bottle heater also has a ground wire that's going to chassis ground. So when we want the bottle heater to turn on, we ground that relay that turns the heater circuit on. It starts to heat the bottle up. And then we turn on and off the heater based on the bottle pressure, all based on the sensor reading. This again makes sure that we have consistent bottle pressure, which is a huge key variable to getting consistent nitrous flow, consistent power output out of our engine. Then we also have, to finally finish out looking at all the components here on the picture, we're going to find that we have a single nitrous jet, and this is jetted up to, let's say, 100 shot. So we want to progressively control 100 shot worth of nitrous into our engine, and now we know all the components within the subsystem to make this work. So the first thing I want to do here is go to our nitrous bottle pressure control. Let's go ahead and...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.